Okay, now we're going to talk about problem number 4, which is, or problem number 3, I'm sorry, which is Tactics Box example 3.3. Basically what they're talking about in here is how to find the components. You have one vector and we want to break it into two components. Why do we want to do that? Let me just review that real quick. If I have these two vectors, A and B, I can talk about this A plus B, and that's exactly the same as if I talked about it this way. Let's call this C, where C is actually the resultant vector. These are two ways of talking about the exact same thing. Well, why would I choose to do this one instead of this one? This seems like double the work, right? Why not just deal with one vector instead of two? Well, normally that would be the case, but when you're dealing with motion, let's say motion of an object that's kind of falling in this general direction, this object has motion both in the horizontal direction, see its position is changing, but it also has motion in the vertical direction, see its position is changing vertically. Mathematically, it's going to be a whole lot easier for me to deal with this as two separate problems. I can say, what is its behavior horizontally and what is its behavior vertically, and deal with that as two separate problems. And that is the direction that we're going with these. So for now, you're just learning how to do the math. We're going to take a vector like this that's at some angle and break it into two. In this case, it just so happens we're going to break it into a vertical and a horizontal component simply because that's going to make our math a whole lot easier. So that's what we're doing here. That's what they're talking about in this tactics box. They're talking about how to take this vector and using some simple trigonometry, break it into its horizontal component and its vertical component. If you know the angle, then the x component here would simply be cosine of the angle. Now because it's pointing to the left, it's negative. And this one, of course, would be the sine of the angle. Again, it's negative because it's pointing down. So that's the tactics box, but of course on the screen they're asking you to do something a little different. So let's go look at what they're actually asking you to do. Well, I can see it, you can't. There are two figures here, so make sure that you deal with both figures. The first figure, it looks roughly like this, roughly, and they've given you AX, AY, and then of course the resultant vector here. Now how did they get this resultant vector? Again, if I just take, I can look at this as a sum of two vectors. If I take AX and add AY to it, just take AY and slide it over here, then this is the sum of these two these two vectors. So they're asking you two questions. The first one is they're asking you, what is the magnitude of the AX vector? Well, for this one, you can just come project it up here and read what is the difference between this value and this. This is at about 8, and this is at about 3. So the magnitude of AX is about 5. The second thing they're asking you is, what is the sine of AY? Well, AY is pointing down, therefore it would be negative. By the way, what would its magnitude be? They're not asking you that, but let's just look at it. If you project over here to the axis, this looks like it's somewhere at about -2, and this appears to be somewhere at about minus 4, it looks like. So the magnitude of this particular vector is, the magnitude is 2, the sign is negative. Now for part C, they're asking you to look at figure 2.2. So you have to, on the screen there, in Master in Physics, you have to click on the arrow that takes you to figure number 2. Figure number 2, let me draw that so we can discuss it here. Figure number 2 looks roughly like this. Here's the axis, and it's over here. They've got BX and BY coming down like this, And then of course B is right there. Okay. So what they're asking you to do is to find the x and y components. Now they've actually already done it for you. They already drew the components on here, and this is pretty easy. All you have to do is just literally read off the axis. So they're asking you to give the, they're saying combine the information, express your answers, we want to know. So you combine the information to find the x and y components. So I guess they're just asking you for the value. Well, bx, if I project it down to the axis, this looks to be about -6 right there. This looks to be about -3.5 maybe. Oh, that's 5.5 on this side. That looks to be about -5.5. So eyeballing it, it appears to me that this is about 2. But of course it's pointing in the negative direction, so the value of bx is going to be -2. Now let's estimate by. Let's see, if I project this over to the y-axis, this appears to be coming at it about -2, and this appears to be coming in at about +3. So it looks like I've got a magnitude of 5, and the direction of course is down, so it's negative. So those are the two values they're asking you for. You'd have -2 and a -5.